The broadcast is now starting. All attendees are in listen-only mode.
All right. I want to welcome back everyone for the KevCAM night class tonight. Tonight is just going to be me, myself, and I. So try to get all your guys' questions answered right away. And I do see everybody that is in there. Yeah, it looks like everybody has been to a night class before. So we won't go through all the boring stuff. But what we are covering tonight is more or less what's a better tool path for my 3D part. And that really comes down to more or less the part than anything at all. So what we can do now is we can use different strategies, and and this is actually a customer one. They want to know, when should I use iMachining or 3D iMachining versus HSR, and when should I use HSM versus HSS. So we'll be covering that tonight for you guys, and so that being said, we'll get the ball rolling for you. So tonight, you guys might have seen this part before, and what I'm going to kind of go over is, first we'll go over roughing, and then we'll get into the finishing side of things for you guys. So first thing we'll do here is I need to expand down my list to see we got more people coming in here. And so as we're coming through this part, what is the best tool path to rough this out, and the benefits versus iMachining versus HSR. So iMachining is going to look at the entire model for you guys and machine off anything in between, leaving that floor and wall offset that you guys specify. Now, if I open up this operation here, and what we're doing here is it's just looking at the SolidWorks model versus your stock. So to use 3D iMachining, you guys will need to use stock, where HSR, you don't need to have actual stock there. So that's kind of back and forth there. Now, when it comes down to tooling, for a part like this, if you ask myself, I would definitely 3D iMachine this out. But if you guys talk to other guys, they may want to use HSR, and the different tool paths in there. I'm kind of going back and forth with the differences here, but the reason why I would go with iMachining is, one, I can use my flat end mill, so I can use my roughing end mill to go in there and rough everything out. You can use a ball end mill with 3D iMachining, but you're not going to get as good of a cycle time and tool life as you guys were to use a standard flat end mill. So right here, we'll just use a flat end mill. Now, my favorite with the 3D iMachining versus HSR is I really don't have to do much at all. All I have to do is pick my tool and then set up my technology wizard on how fast do I want to machine this part. So if we're clamping down, well, so right here, if we turn on the path, you can see that we're going in there and we're using our patented morphing spiral and going in there and coming all the way through. The big thing is our scallops. So with our scallops, your scallop size is always going to remain the same of what you specified in the technology section. So right now the scallop is set to 61 thou, where if we use HSR, it's going to be based on step downs and step overs. So what I mean by that is, if we get a side view here, going up a more vertical wall, our tool path is going to be spaced out a little bit farther versus in a flat area, where if we were to use HSR, it's going to be much closer together coming down a steep wall because we're doing a constant step over or constant step down. The thing that I really like about the 3D iMachining versus the HSR is when I come back to finish this part, I know all my scallops are going to be at this 61 thou or whatever you guys specify right here, versus if I'm using 3D HSR, my scallops are going to vary quite a bit, depending on if I'm going up a vertical wall or a more linear wall. So it's it's kind of an all-around great tool path, at least for myself. And for the other years I've been programming, I would definitely use, just my personal opinion, but I would definitely be using 3D iMachining over any roughing strategy out there, just because it's very easy for the end user, for you guys to program. Plus, we're going to get a lot better tool life, but we're going to have very good consistency on that scallop height. So when we come back to come finish this up with a ball end mill or a bullnose end mill, we're going to have nice, good finish. Where HSR, you're going to have a lot of inconsistencies just because the scallop height is constantly changing based off of a vertical or a linear wall, or more flat. So those are the big differences between 3D iMachining versus HSR. Like I said, I try to use the 3D iMachine absolutely as much as possible. Even for our prismatic parts, I will try to use 3D iMachining to go through and get all that material out of there, even though that's still going to leave a 10 thou or 15 thou on your wall and floor. You guys can always come back and finish that up. But there's a lot, I think we talked about this a couple of years ago, where you guys can actually use on prismatic parts or 2.5D parts, you guys can actually use full 3D tool path just to make it very easy. So transitioning over to the HSM. So right here, we're doing a HSM Horizontal. Now this is another one that I will use a lot for prismatic parts, just because what it's doing is it's looking at anything that is 0 degrees, and it's going to machine the flats for you guys. So if we look right here, it's more focusing on the flats tops right here, tops right there. Anything that is flat, it's going to come in there and hit for you guys. So you guys can do your 3D iMachining, get everything roughed out, come back and do your horizontal, and it's going to finish off all the floors and walls for you without having to do any work at all. Now, so that is more looking geared towards the flat stuff. Now, if I can give you a very simplified version of when should I use HSS versus when should I use HSM, it's very part dependent. So what HSM is going to do is it is going to lay a blanket over the entire part. So when we're inside of, open it back up here, when we're inside of HSM, it's just doing a boundary. So we're basically telling it to machine anything inside of, let's do a show here, of this boundary right here. So it's going to look at all the geometry inside here, where HSS is going to be more or less your fine tuning. So if you want to go in there and fine tune a specific area, for say like this surface right here, or doing a radius, that is where HSS comes in. It works absolutely amazing. So let's kind of go through this part here. So this one, we're with HSM Horizontal, we're just cleaning off all the flat areas. We'll go to our next HSM, and this is going to be doing our 3D corner offset. So especially with a part like this one, we have a lot of bosses sticking up, plus a lot of round faces. So there's not one tool path that is going to work perfect for this part, just because there's so many different angles and surfaces and all that. So with the 3D corner offset, we'll do is it will come on there and mimic any geometry that's there. And what I mean by that is, as you can see, like this radius comes around right here. The tool path will actually start blending over to follow this tool path to go along right here. So it's a very nice tool path to kind of flow with the geometry. And what it will do is you'll see that we're not touching any of the flat areas, so we're not recutting anything, and that is all set up by our passes telling it that we are going to machine anything from 0.1 degree to 90 degrees. So if I had this set at 0, it would also machine the flat areas as well. But like I was saying, we would not want to tackle this entire part using HSS, because what would happen is we'd have to break this up into many different regions. So like I said, HSM works very good to throw a blanket over the entire thing. Now, HSS is specifically designed, and hopefully I'm not repeating myself here, but to work on just single surfaces or a couple surfaces together. So if I want to do this little piece of radius right here, but I also want to do the radius that is over here, we would want to break that up into 2 operations, because we have 2 surfaces that are completely opposite sides of each other. And HSS would probably do a little bit more bouncing back and forth, versus where HSM, we're looking at the entire geometry to go in there. And like I said, if you guys have questions on this, please let me know, because I know this is pretty deep stuff here. Where HSS also works very good is if you guys have like a radius around the outside of a part. The morph between boundary curves is actually probably one of my most used ones, morph between boundary curves or parallel the curve. And what we can do by that is, let's say we have a finish call out for these radiuses right along here, and possibly along here, possibly along here. And that way you guys can machine this entire thing out using HSM, but instead of sending it off to the polish shop to come and get this polished, you guys can actually come in here with HSS and just do this area. And like I said, keep it contained. Try to keep your surfaces connected. That is one thing that we see quite a bit on the support is people will try to do, for instance, all 3 of these different zones right here, and they get a lot of bouncing around. And what you can do is, it's better just to keep it contained just to a certain area versus trying to do multiple different areas. So with this one right here, we're coming in there and just doing some pencil milling and rest machining to come and clean up some leftover radiuses with a smaller tool. HSM works very well using rest machining, where HSS does not pick up any rest machining at all. There are some options in there to actually get your stock brought in from the solid verification to see what needs to be cleaned up, and I'll cover that shortly here. But HSM has a much better technology for rest machining than it does in HSS. Now, the big difference between HSS and HSM is when we do our part right here in HSM, if we go to our geometry, it's looking at the target. So what's happening is the target is actually turned into facets, which is triangles, and it makes little tiny triangles through the entire part. So when I say it lays a blanket over everything, take that model and just put a bunch of triangles in there. You won't get as good of a finish using HSM versus HSS. So HSM is using the facets of the model, where HSS is actually looking at the SolidWorks surface NURB itself. So long as we have a good surface there, you will get an absolute beautiful finish using HSS to go in there. And like, that's kind of why I call it the surgeon scalpel. So, you whack it open and then come in there and fine tune that specific areas that have a higher finish call out. And if we're not looking for a high finish call out anywhere on the part, then definitely, and this is kind of more geared towards the molds, definitely go to town using the entire HSM. One of my go-tos for HSM is either the 3D corner offset, so we can get that tool path to blend and follow these surfaces, or doing the HSM 3D constant step over. So what we're doing here is just kind of doing some cleanup work from the leftover tool. So it's a real nice feature inside HSM to use that rest machining. Now, if we move our way down here, open this one up, we are doing our 3D constant step over, like I was just telling you guys about. So what we did here is we contained it just to a specific area. Doing boundaries inside HSM is very simple and easy to use. So if I just do a show right here, all I did is chained this outside top ring going all the way around, and then I just kind of jumped over this piece over here by doing point to point and then continued chaining around. So what we're actually telling it is we want to do a 3D constant step over contained to inside this boundary. With HSS, there is no boundary. Your boundary is the surface that you clicked on, and it's going to work on that surface. You can limit the boundary down by telling it to do a check surfaces under the gouge check, by telling it to click on all these different surfaces, but you're going to be doing a lot of clicking. Where right here, all we did is create a boundary, and it's just doing a constant step over inside there to keep that tool path, versus HSS, I would have to come in here and click, you know, all these different surfaces, all these different radiuses to go all the way around. It's going to take some time, and we're on something like this, what we'd probably want to do is break it up into sections like I was saying before. So if we're looking for a really good finish call out just for the surface right here, what I would do is use a HSS. Let me hop out of here, and I'll turn off the tool path for you guys. So what I would probably do on here is do a HSS morph between boundary curves. So what I can do is I can select this edge all the way around, and then my start curve would be the top of the chain, and my end curve would be the bottom of the chain, and it would just do work contained to that area. So like I said, it all depends on surface finish, but as well as the part itself. Now, if I had a million parts for you guys to show you guys, we can go through and say, oh, this one I would use HSM, or this one I would use HSS. I guess my kind of rule of thumb is if you have kind of a mold, or, you know, multiple surfaces, or different areas, kind of like this part, that's where HSM really shines. If we're just looking to do a specific area, that's where HSS is going to help out. So we got that 3D constant step over to do that area. Now, oops, is this the one I just did? No, so this one we're kind of containing it just to do a radius right here. But what happens right here is you'll see we kind of have a gap in here. And it's all to do just with the step over or the step down of what's going on. We can go to our passes and see that we're doing a 30 thou. And if we change this down to maybe 28 thou, it would do another pass in here. Now, if I was to do this with HSS, I would do, like I was just telling you guys, using morph between boundary curves, and we could come in here and grab this, and I think, no, I didn't set one up on this one. So I would do our HSS, grab these three surfaces, and do that as well. So they're each very different, but very similar in all the same way. So and that's why if you guys have bought our 3D Pro package, it comes with HSM and HSS, because they kind of they go back. You'll use it back and forth quite a bit. So that's keeping it contained just to a radius for HSM. Now the spiral works good to pretty much get that pretty look. So just did a small little spiral tool path right here. This is one that I also use on my 2.5D parts quite a bit for doing pockets to do finish off a floor, especially where if it's a part that the consumer is going to see they can see the machining lines in there, you get a real nice spiral going in there to machine the lines out. But we don't have to do a whole lot in there. Now, I've been talking about boundaries and keeping it contained to a boundary where HSS can do surfaces. HSM can also do surfaces as well. So if I switch this over, I can do it by selected faces. But it always seems to me that doing a boundary, just a chain boundary, is much easier than going through and clicking a whole bunch of surfaces. So you guys do have a lot of different options here. You will have more toolpath options, as you can see right here, using HSM versus HSS. But like I said, they kind of go hand in hand with each other. So for an HSS, like you were saying, that surgeon scalpel, my mouse is glitching out here. So we'll just say that we had a print call out to have a very smooth finish on this radius right here. And like I was telling you guys before, if we were to do this, we could wrap it around. This one is just a specific call out just for this area right here. So if I go ahead and open this up, if I go to my geometry, I'll turn off my tool path and to show that these are the fillets that I just want to work on. That's my main focus, just coming in there and fine tuning that surface. So I'll get a really good finish, and you have a lot of control of what's going on there, especially when it comes to the gouge check, telling it to stay away from all these surfaces here. So basically what I did is just, and if you guys are kind of new with HSS, when you guys grab this, instead of having to click on each one of these surfaces, there is a button where it says all adjacent drive faces, and that will automatically pick up everything for you. Now, and sometimes with HSS, you can see that there's just a small little sliver there, so we may need to add some additional control and add that one in there as well. But so you don't have to go through and click every single one. You guys can use the all adjacent faces as well. You do have a lot of control with your linking strategies. So instead of gouging in or doing on my check surfaces, I can tell it to retract the tool. Usually my go-to is trim and relink the tool path, because I want to hit as much as possible while I'm using my HSS. So it's going to relink the tool path and keep continuing on. Or you can set up to stop the tool path calculation, or we can just do a report a collision, and it's going to tell us where it's going to go. Now, like I was telling you guys before with the rest machining, there is the option to do the stock definition, and you can actually tell it to stay along the stock, and that's going to eliminate a lot of air movements. But you can also fine tune it so you're just cutting some rest material, but it's, like I said, it's not as good as what you would get with HSM. I'll top out of here. Now, let's say we had a really high finish call out for this bowl right here, like where a bearing ball would be sitting in there. We would also do HSS for that as well. So we'll just do a quick one here. And my drive surface is the surface you want to cut. So I want to cut that bowl. Start curve, I want to start up here, just like that. And now my end curve is going to be the bottom. So it's going to start at the top and just work its way down, doing a zigzag pattern going in there. Green check mark. We'll go ahead and grab our tool. And we'll just use, I got a 375, quarter inch ball will work. 1/8 inch will work. So now from right here, for those of you guys that did watch the HSS classes, that's the only thing I'm going to come in there and do. So I'm going to do save and calculate. I'm going to set up my area that I want to machine, and the tool. And I always want to get a tool path to kind of see what I'm looking at. I don't want to come in here and start fine tuning stuff if I have a huge rat's nest in there. But I can see I have a very good tool path. I got good control, and I'm just coming in there, just doing a zigzag, working its way back and forth. Now, to me, it seems a little easier is the linking in HSS. So if I come in here, you'll see that we're just kind of moving straight down and going over. So, and you can control this with HSM, but I just find it a little bit tougher in HSM versus HSS. So what I'm going to do here is I'm going to tell it to do a blend spline for these. And what it should do is round our corners here. Let's try to do blend spline. Here we go. So now what this will do, instead of doing those harsh movements where it comes to a straight 90 degree, moves down, for that moment in time, that machine is coming to a stop, and sometimes we'll get a witness mark there. So if we're looking for that 100% ideal finish, then I'm going to do my blend spline. So as it's coming through, it comes down, keeps in contact, does an arc, and then swoops down and keeps going through. So now, if we go in there and fine tune it just a little bit more, it's set up as a 50 thou step over, or having a scallop of 5/10. Since we're looking for a really good finish in there, we're definitely going to want to tighten that up. So we'll shoot for a 5 thou in there. You can see we have a lot of tool path in there, and this is why I like to kind of leave this for the end, just because you get the lines get overlapping, and gets a little tough to see what everything's going on. But if we kind of zoom in there, you'll see we have nice, smooth flowing lines through there for that fine detail of a finish. This one is one that I would not use HSM, just because I think I'm going to be doing more playing around to get the tool path that I'm looking for. And I guess what we can do is, I can show you that. We'll do a HSM. And we will do a offset cutting. And I'll grab that same tool as what I used before. Tool number 4. Drive boundary. So my curve I want it to follow is going to be this one. And constraint boundaries, what I'm going to do here is do by selected faces, kind of like what we're doing with HSS. So we got our drive faces, kind of like HSS, as well as you can set up check faces. So if I do define here, I can do the adjacent faces. And from right here, we'll go ahead and take that. And, oh, did I grab the wrong one here? Need 3D corner offset. Sorry, that's what I was looking for. So we'll do create manual, selected faces. Can I grab that? And, okay. Now let's see what that looks like. So you can see right here, I'm not getting that clean swooping line to go all the way through. Let me kind of rotate this part around here. So what's going to happen here is all these little connections, they do have little radiuses in there, but as it's moving down, it's not going to have that beautiful finish that we're looking for. So you actually see a little tiny witness line going through there. Now up here, we're going to have smooth tool path, but as soon as it hits this adjacent pass right here to move over, that's where we're going to get our line. And we can fine tune this to go in there and just do a zigzag going back and forth, but there's going to be a whole lot more time in there. So I'm going to have to go to my passes, and we can edit our passes here. We can do our actual offset, but the linking, we have a whole lot of stuff in here that I'm going to have to, let's say, tinker with to get that exact tool path where HSS, grab the surface, start curve, end curve, and tell it what you want for a scallop, and you're going to get that beautiful tool path. You'll notice right here, if I zoom in, we're going to have a different finish call out just for what's going on right here. So our tool path is going to be overlapping itself, and then it gets wider, and then as it gets back over to a point right here where it can't go anymore, it's going to move over to the next level. Where if we compare it with the HSS, it's just going back and forth, back and forth. So the tool path, the scallop, everything is going to be a consistent finish for you guys. So, is it gouging? Yeah, it definitely could be. Let's go. So HSM, you don't have to worry about gouging into the part. HSS, you will have to double check everything just to make sure we're not gouging in there. So let's go ahead and open this up. And we'll go to our gouge check. We'll enable it. And so now, I'm guessing just because our could be our graphics, but it does show kind of bouncing in and out here. Let's try. So you can get a little bit better view here, but this will eliminate any gouging. And what Ronnie's asking there is, by looking at that tool path, it looks like it's kind of going through the material and whatnot. So by turning on our gouge check, we're telling it that that ball end mill will not gouge into the drive surface with the tool shaft or the tool tip. Now we can also do, instead of doing retract tool, we can do trim and relink. And I don't think it's going to change much at all here. Yep, so we're getting the same exact tool path there as well. So HSS is going to be the go-to just for working on that specific surface. Oh, Ronnie's telling me HSM is gouging it. Is it? Let me turn this back on. I think it's just the surface view, Ronnie, just because I'm getting that same result in that same area with the HSS. Inside here, go to, trying to look here, passes, edit passes. So there is gouge check while linking, and what the linking is doing is from right here, let's zoom in here. So from this path right here down to this path is a link. So it's linking between its lines. We can turn on gouge check while it's linking between each lines. And this more comes in handy if we're doing something along the lines of this right here. If we see some of the linking possibly gouging, when you guys play it through in Solid Verify, you guys can turn that on and do a gouge check for the links. So it will not gouge check inside there as it's linking or repositioning into a different surface. But like I said, HSM, there is no gouge check in there because it's going off of the faceted model for you guys. Any other questions, guys? So we did a lot with HSM here. Let me pull up a part that actually all of you guys will have. And it is, if you guys go to your SolidCAM Open and go to the Getting Started examples. Open. Now, one thing I forgot to mention with HSS, and this part reminded me, is if we wanted to do, I just seen it here. This right here. So let's say we wanted to machine this face right here. Well, what would happen is in HSM, if I expand that boundary out, so if I tell it to expand out to do external, what's going to happen is it's going to follow the geometry itself to go down. So you actually see your tool path dipping down and then coming back up. Well, I don't want to touch this wall right here because it's already finished by side milling with a different operation. So what you can do with HSS is you can expand that surface, but it's not going to go down. It's just going to take that surface and basically, if you were in SolidWorks, you did a offset surface, is exactly what's going to do for you, as well as the ability to skip over holes and slots and all that stuff. So if we come in here, you'll see that our tool path is not going down inside this hole or the slot. It's just basically carrying straight across for us. So in the link section, which is very powerful, I'll open it up here. In the link section, we're telling it to do follow surface for any large moves between the slices, and then for any gaps, we are doing a direct. So by doing direct, kind of see if I can get this to follow down here. So if you see my picture right here, if we're doing this surface, and we have a drop off there, we can tell it to not go down inside there and just do a direct move from right here to right here, where if we were in HSM, it would definitely drop down in there as well. Now with HSS, I do like is if we have a specific area that I do not want it to touch, what you can do is actually draw a sketch on there and just throw it on a top plane or right side plane, what plane that you guys are working on, and we can actually use the 2D boundary and we can keep it contained just to a specific area. Now we can't do the reverse of telling it to machine everything but a circle, but what you guys can do is if you, at that point, you guys can create a surface on there by doing a sketch and just doing a quick little surface, and then you can use that as a gouge check and tell it not to touch that surface as well. So let's see, Ronnie, I just want to know why I can't get these easy parts for programming. For those guys, I like to pick on Ronnie a lot, and Ronnie has some of the most ugly parts I've ever seen as a machinist. So yeah, I feel for you, Ronnie. So this part was done a lot with HSS. So just for working on specific radiuses, so let's say like this one right here, HSS is your ticket, and I think we actually have some tool path on, yeah, right here. So I'll just unselect those surfaces. So we're just telling it just to work on that specific surface. And what we're doing here is doing a morph between surfaces. So with that morph between surfaces, I told it to stay, you know, start at this surface and end at this surface. So I'll do a show. So that's my start surface is the top of the radius, and the end surface is going to be the bottom of the radius. And some of the flat. So we're telling it to stop right here. Now the difference between morph between boundary curves, describing a line versus morph between surfaces, to be honest with you guys, I cannot tell a difference yet. I'm sure I'm going to come across it where it does matter, but to me it always seems that the morph between boundary curves is a little bit easier than going off of a surface. And the only reason I say that is with a curve, what it's doing is it's just doing a projection straight up, where if we're doing it on a surface, what you guys can actually come into is, if I do an edit right here, and Let me turn off this tool path real quick. I'll do edit. On some imported surface parts, you may get directions showing the wrong ways. So right here, our directions are pointing up, and this is our drive curve. But for your adjacent surfaces, you could have your surfaces pointing in the opposite direction. Now you guys can go in there and change the direction of that surface, but it's a little bit more work, where if you just grab the line right there, the edge curve, we know it's going to be good no matter what. So on a part like this, how I would machine this out is I would start off with 3D machining, come in here and get everything completely roughed out. Then what I would do is come in here with my HSM Horizontal to get these flat floors and vertical walls, as well as doing just an outside perimeter machining in there, and these little flat areas right here. Then what I would do is come back with my HSS, and if I zoom in here, you'll see this little tiny radius. I would grab that radius going all the way around, and I would do a morph between boundary curves. And what I really like to do is, let me just see this path real quick. So this one, let's see if we got one on this. Oh, this one right here. So let me open this one up. So what I would do on this is, under the tool path parameters, instead of doing a one-way, I would do a spiral. And I would do a spiral for a lot of these radiuses that have a continuous radius going all the way around. So like we got this top radius, we got this inside radius, we have this chamfer right there. You get a really smooth finish, and that way you don't have any transition points, because it's constantly stepping over that amount using that spiral functionality. So that is a huge go-to. So like I was saying, so I'd use my HSM, even though it's flat, to get all the flat areas, and then fine tune it. So HSS for this radius, outside, inside, we have this front radius right here, these front radiuses, and that is it. So that's kind of how I would tackle that part. But like I said, I mean, what the suggestion was for the night class is, when do I use HSS, when do I use HSM, when do I use HSR, when do I use 3D machining. Hopefully that gives you a very wide picture of the differences in how to program which tool path is going to be better for your part. But like I said, and I'll say a whole lot when we get into this 3D work, is it's all dependent on the model itself. So if we have a very complex model, like when we were looking at the previous one, a lot of bosses, a lot of radiuses sticking out, HSM is the winner there. Where in here we have a more simplified part where there's not a whole lot of 3D areas, and it's all flowing together. All the radiuses are flowing in with each other and stuff like that. That's where HSS is really going to shine for you guys. So, can you use the spiral HSM instead of the HSS on the countersinks on that? Yeah, I think we can, and we'll do it. So let's come in here, and we'll do our spiral machining. And we're using tool number 4, constraint boundaries. And this one we'll just do by selected faces. So we can kind of compare apples to apples here. Define. So that's my surface that I want. And then my check surfaces, I'm going to do all adjacent. Let's try our passes. So let's just take a peek at what we had our step over set to. So if we go to toolpath parameters, so we had a 0.2 millimeter step over. Let's see what we had here. Do a 0.2 millimeter step over. So you can see it's not, it's about as easy as it is with HSS, but here's the only thing I see is, so we have consistency coming down, but as you notice, it's starting to get farther and farther away. But you can see our toolpath is, since we're working off of this faceted model, we're not getting our smooth lines in HSM like we were with the HSS. Now my toolpath's not going to turn on. Oh, I'm clicking on the wrong one here. So you can see we have nice smooth lines versus our HSM. It's getting just a little bit jagged, and we can go through and smooth that all out, but that's more fine tuning that you guys have to do. So yeah, so you'll get the same result either way, but as the programmer, you may have to do a little bit more work. But here's the other kicker that I'm not liking is here's HSM. As it's ending the boundary, it's dropping down inside there. Got a little spiral going on there. Now, what I can do to eliminate some of that, if I open up my HSM spiral here, I can tell it the Z bottom to go to that line, and that may eliminate Yeah, so we're still getting some curly cues in here as it's coming around. I can't give you an explanation why, and like I said, we can go on through there and go to our ramping, and we can switch our ramping around a little bit so we're not getting that, but it's more playing around. And if we were to run this on your machine, we're going to get a better finish using the HSS versus the HSM, just because we're just working on one specific surface. So hopefully that helps you out, Ronnie. Any other questions, guys? Rick, Carlos, Scott, Bob? No. All right, I'll stop calling you guys out. But no, so I guess that's kind of the main thing I want to show you guys is how, when to use HSS, when should you use HSM, versus for your roughing strategy, when should we use 3D machining versus 3D HSR. So hopefully that gives you a good comparison of what's going on. Now, next week, we don't have anything signed up, so for the next classes, what we are going to be doing is we're going to be kind of starting over. We're going to start covering face mill, profile, all that stuff. And the only reason why is because when we started these night classes, for those of you guys that remember, I know Ronnie and Rick McAllister, you guys have been here pretty much from the beginning. That was probably 2.5 years ago. So we need to update these, and there's a lot of new stuff in technology with the 19. So we're going to be kind of recovering that, but I'll try to add in some lot of new stuff for you guys. So for those of you guys that have sat through all the night classes, it won't be just a fall asleep because you already know all the information. So we'll keep it interesting for you guys. But that's all I have for tonight. Any questions or concerns, please feel free to reach out to me. I know all of you guys have my email address. For everybody that's watching on YouTube, shoot me an email. My email address is in the description. And we will look forward to talking with you guys. I think we can do a night class next week. I don't think I'm traveling for once. So we should be able to do one next week, but just take a look at the website to sign up for those classes, and those are, if you just go to solidcam.com and make sure you're on the US flag here and click on webinars and KevCAM night class, and all the class lineup will be in here for you guys. So, all right, have a great evening. I just want to thank everybody for sitting through this, and hopefully you got something out of it. But let me know if anything comes up and what we can do to help you guys out. All right, guys, have a great evening. Bye-bye.